Can you see the screen?
Yes, ma'am, I can see.
Okay, so we were discussing about what is equally likely, what is not equally likely. So here we have already discussed this concept. Just a recap that here the first one was the driver attempt to start a car. If if we will be focusing on the sentence here, it's talking about a particular driver, right? Can you see? Here it's talking about a particular driver, the driver attempt to start a car. So it's not just any random driver is starting, a particular driver is starting. That's why we are thinking about whether the driver is where- and like a driver is starting the car. It's not experiment, it is not said that it's just randomly we are picking anyone, and whether the car like randomly we are taking the car, whether the car will start or not start. Here the question doesn't say like a trial or an experiment has been done. Okay, that's why we are considering whether the car will be in good condition or not good condition. So that's why we said that it is not equally likely. Similarly, in the other one, we are saying a player attempt to shoot a basketball. So the same thing, we are considering whether the what is the ability of the said player, what is the whether he was prepared or not prepared. So that's why we are saying it's not equally likely. But for the last one, a trial is made to answer a true false question. Whether the question will be right or wrong, it's just a experiment based question. Randomly, you are picking the like true false question, whether you are answering true or you are answering false. So it can be right or wrong. The chances are equally likely, right? This much we have discussed till in the next class, right, Jesleen? Yes or no?
Yes, ma'am.
Okay, let's move ahead. Let me take one example. So there is one example that which says that find the probability of getting head when a coin is tossed once. So when we are just flipping a coin once, what is the probability of getting head? Okay, so sample space, that means total number of outcome. It can be head, it can be tail. Now probability of getting head means there is one favorable outcome, right? So probability of getting head will be 1 by 2. This is very basic concept. When you just started learning the concept of probability, then you must have done this one, right? Now probability of getting tail will be similarly, probability of getting tail will also be favorable number of outcome by total number of outcome. Now from here I want to show you one concept. That's why I have picked very simple question. So I want to show you that probability of head is 1 by 2, and probability of tail, which can be written as probability of not head, that is also 1 by 2. So from where we are from here we are getting one relation, that probability, just a moment, probability of not head, or in other way we can say tail also, can be found as 1. That is the total probability, like that is 1 sure. When we are sure, the probability is 1. From there, if we will subtract this one, the head one, we will be getting the probability of not head. Okay, so let's do the same with the another problem so that you can understand in a better way. So I want to say a bag is there. Okay. In bag there are a red ball, one red ball, one blue ball, and one yellow ball. All the ball being of same size, Kritika takes out a ball from the bag without looking into it. What is the probability she will be taking out a yellow ball? So probability she will be taking out a yellow ball. Out of how many ball? 3 balls. She is picking one ball. One is yellow, right? Similarly, probability of taking out and probability of okay. Yes, Madhya, we are continuing with the same. Okay, the probability. So probability of just picking a yellow ball will be 1/3. Probability of picking a blue ball will be 1/3, and probability of picking a red ball will be 1/3. From here, we are seeing that if we will add all of them, probability of yellow plus probability of blue plus probability of R red, it will be 1/3 plus 1/3 plus 1/3. So every time, whenever whatever probability you are finding of head, just a moment, let me check what happened. Can you see the screen?
Yes, ma'am.
Okay. So here we can note that probability of yellow, probability of blue, probability of R, when we are adding it, the outcome is 1, right? Similarly, in the other first question, if we are adding probability of head plus probability of tail, it will be 1/2 plus 1/2. That is 1 only, right? Can you see it, the relation?
Yes, ma'am.
So here we can say that when we are having elementary event, like all are equally probable, like all are having equal probability, then once we will add them, the result or the outcome will be coming out as a 1. Probability of this one, probability, if you are talking about one event, one experiment, and in that experiment whatever event has occurred, if you are taking all the probability and when you are going to add them, the result has to be 1 only. Okay. That's why we say that whenever we have to find probability of, let's say, tell, then we can also find this as probability. Sometime while doing the problem, it's not like easily it's not possible to find the probability of getting tell. So that time what we'll be doing, we will be taking probability of not head. If you we know already probability of head is 1/2, so probability of not head will be 1 minus 1/2. This not head is called tail also. So this plus the probability of first event plus second event plus third event is equals to 1. This condition or this relation only we are using it over here, right? That total is 1. So if you have to find one thing which is missing, you can subtract it from one the other thing, right? Are you getting it? So yeah. So in general, it is true that probability of event E complement will be 1 minus probability of E. Okay. Now let's see where we are using these conditions, or let's apply those in the questions itself. So the first fill in the blank says probability of an event E plus probability of an event not E is equals to what? Probability of E plus probability of not E. Probability of not E is equals to 1, right? Now only we have discussed probability of head plus probability of tail. Instead of tail, we can write not head. That has to be 1 only. Yes or no?
Yes, ma'am.
Now the next fill in the blank says probability of an event that cannot happen is any impossible event probabilities. Previous day only we were talking about the probability line which lies between 0 to 1. 0 is impossible, 1 is sure shot. So which is impossible, that's probability is 0, right? And such event is called impossible event. Yes or no?
Yes, ma'am.
So now the next one, the probability of an event that is certain to happen is called, that is certain is called like
Sure event.
yes, what?
Sure event.
Yeah, and that's probability will be 1, right?
Yes, ma'am.
The sum of the probability of all elementary event of an experiment, as I said to you, all elementary event, like one by this, one by that, one is the probability, like there is 6, like we are just throwing a die. So 1, 2, 3, 4, 5, 6, these are the total sample space, like all the outcome. Now if I am talking about probability of getting 1, it is 1 by 6. Probability of getting 2, it is 1 by 6. Probability of getting 3, it is 1 by 6. Probability of getting 4, it is 1 by 6. Probability of getting 5, it is 1 by 6. Probability of getting 6, it is 1 by 6 again, and probability of getting 7 by 6. And once you will add all of them elementary even, so the result will be 1 only. Okay. Now the next one says the probability of an event is greater than or equals to dash and less than or equals to dash. So probability of an event, just a moment. Have I explained that in the previous class? So probability, as we know, it will always lie in between 0 to 1. So probability of any event will always be greater or equals to 0 and less or equals to 1. Okay. Now likely, not likely, that we have already discussed. Number 3 says, why is tossing a coin considered to be fair way of deciding which team should get the ball at the beginning of the football game? Why is tossing a coin, like it's said to be fair, like that's the fair enough measure to just take that in consideration when two teams are going to play? So obviously when we are going to toss a coin, two teams are there and a coin is having two sides. That is the fair coin. That is not the just magical coin where both sides are head. That is not a magical coin where both sides are tail only. So that is, if we are talking about a fair coin, that means uh, unbiased coin. Here everywhere it will, unbiased word will be used. Unbiased, which is not biased. Okay, that's fair. So fair coin we are using where if you are having one of the side as a head, there is another side as a tail only. So obviously there are two sides and having equal chances of, like there is a equal chances of happening, like equally likely, both are equally likely to happen, head and tail. 50% chances there that head will occur, 50% chances there that tail will occur. So obviously this is the fair enough measure to take that in consideration when we have to decide which team is going to play at first. Yes or no? Right? Let's move to the next one. Which of the following cannot be the probability of an event? Which of the following cannot be? You know probability lie in between 0 to 1. Okay, and the chances, if we are talking about, it's all if it is given in percentage, you can already always compare. Just if it is given in percentage as a 15%, you can just convert it in fraction and then you can check it. So that has to be, the value has to be in between 0 to 1. Okay, or it has to be in between 0% to 100%. So 2 by 3, it's in between 0 to 1, right? You can check it. If you want to convert it in decimal, you can check it. 0.6. So it's in between 0 to 1. So 2 by 3 can be the probability. Okay. One more way is there to decide that the numerator one will always be smaller than the denominator one. Okay. That can be the probability. And if numerator is bigger than the denominator one, if you are having improper fraction, just like 5 by 3, improper fraction, then here you can say here this value is greater than 1. Are you getting it?
Yes, ma'am.
Okay, so let me write all the options. 2 by 3 minus 1.5, 15%, 0.7. 0.7, okay. 2 by 3 proper. Probability line says that probability can be, like probability not can be, it will always be in between 0 and 1. Minimum it can be 0, maximum it can be 1, right? So negative probability is meaningless thing. Okay, 15% is also fine. So are you getting it? Which cannot be the probability? Minus 1.5 cannot be the probability. Getting? Now let's see the next one. If probability of E is given as 0.05, what is the probability of not E? So if you have to find not E, total is 1. Okay. Total I am having 1 chocolate. Okay. And if that is not the better example. So total, if you are having, let's say, total you are having 100 cards you are having. Okay. And the cards are of blue color. Okay. So there are how many red color cards? So let's say red color cards are 25. So the card which are not red, that will be total minus 25. Yes or no? 100 minus 25, right? Similarly, if probability of E is 0.05, then probability of not E will be total, that is 1 minus 0.05. Is it clear to both of you? Are you getting it?
Yes, ma'am.
Okay, let's move to the next one. So a bag contains lemon flavored candies only. Malini take out one candy without looking into the bag. What is the probability that she takes out an orange flavor candy? So there is a bag. Which type of candy is there? Lemon flavor candy. Lemon flavored candy is there only. How many is there? It's not written. But whatever is there, that is only lemon flavored candy. Now, an orange, if you want to pick out any orange flavored candy, is it possible? Is it possible? I want to pick out a orange flavored candy from a bag which is having only lemon flavored candy. Is it possible to take it out? It's not possible. It's not possible. Is not even there. So that probability, that is called impossible event, and that's probability will be 0. Second one says a lemon flavored candy. So from this bag, if I wanna pick a lemon flavored candy, so the 100% chance is there, whatever I will pick, that will be lemon flavored only. That means the probability of picking out a lemon flavored candy will be 1, because probability of sure event is 1 and impossible event is 0. Got it? Let's move to the next one. Now the next one says it is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. There are 3 students. The probability of 2 students, probability of 2 students not having same birthday is 992. What is the probability that 2 students have the same birthday? Probability that 2 students have same birth. Just a moment, let me check. Okay, just a moment now. So probability of 2 students have same birthday. Now we know probability of, like, it's total, we can say it's 1. Okay. And if 2 student not having same birthday is 0.992, then 2 student having same birthday will be 1 minus 0.992. Yes or no? Not having same birthday, not having same birthday is given. Having same birthday 0.992. Are you getting it? Today also it started the same thing which we were facing on the very beginning. Am I audible to both of you?
Ma'am, sometimes it's lagging, but then it's fine.
Let me stop the video. Maybe it will get better. And do let me know if it's not like audible. So not having same birthday is 0.992. So having same birthday will be 1 minus 0.992, right? And from there we will be getting what is the probability of 2 students having same birthday. Are you getting it? Are you getting it? Jasleen and Madhya?
Ma'am,
Yes, ma'am.
I'm not audible.
am I sharing your screen?
Okay, just a moment. Can you see the screen now? Can you?
Yes, ma'am.
So not having same birthday is 0.992. So having same birthday will be 1 minus 0.992. Yes or no?
Yes, ma'am.
Okay. So let's move to the next one, which says that a bag contains 3 red ball. There is a bag which has 3 red ball, 5 black ball. A ball is drawn at random from the bag. What is the probability that the ball drawn is red? We have to find. So the formula is same like the previous class. That's why I'm not focusing on the formula. Do you know the formula? Number of favorable event by total number of event. I mean, number of favorable outcome by total number of outcome, not event. Do you know this formula?
Yes, ma'am.
Total number of favorable outcome divided by, again it will start. It is started. I don't know what exactly happens sometime. If I'll check my internet connection, that will be well and good enough. But still this problem, I don't know why it happens. Let me take whiteboard only, because that is again and again it is getting stopped. Can you see the whiteboard?
Yes, ma'am.
So probability, a bag is there. The bag is having 3 red, 5 black ball. Now the probability of getting red ball will be favorable outcome, that is 3, by total outcome, that is 8. Okay, that is probability of getting red. What is the probability of getting black? That will be favorable outcome, that is 5, sorry, and total outcome, that is 8. Is it okay to both of you?
Yes, ma'am.
Now here it says not it is it's not asking about black. It says find the probability of ball drawn is red and not red. Find probability of getting red, and second case is not red. So probability of getting red is 3 by 8 and not red will be 1 minus 3 by 8. 1 minus 3 by 8, and that is 5 by 8 only. So probability of getting red is 3 by 8 and not red is 5 by 8, which is blue as we can see, right? So we don't have to find blue. We will just be finding probability of red and probability of not red. Not red means blue only. Let's move to the next one. Now the next question says a box contains 5 marbles, 8 white marbles and 5 red marble. 5 red marbles is there, 8 white marble is there, and 4 green marble is there. One marble is taken out from the box at random. What is the probability that the marble taken out is of red color? Probability that marble taken out is red, probability that marble taken out is white, and probability that marble taken out is not green. Okay. So probability taken, marble taken out red will be 5 divided by total number of marble. So 8 plus 5 plus 4. Is it 17? So we got Probability of getting red is 5 by 17. Probability of getting white is 8 by 17. Yes or no? And probability of not getting green will be 1 minus probability of getting green. Right?
Yes, ma'am.
So 1 minus what is the probability of marble of getting green? That will be 4 divided by 17, and that will eventually be the sum of these two only. So let's do it our way. No need to, we will be checking it after a while. But 17 minus 4 is 13 over 17, right? We are getting 13 over 17. Now, if you understand the concept, then from here only you can say that probability of not green means what? Red and white. And red and white together is this and this. If you will add this and this, it is 13 by 17 only. So this is just the concept, but please do it this way, the straightforward way. Okay? Are you getting it, Madhya and Jasleen?
Yes, ma'am.
Okay, so the black one which I have circled and marked, those are just the concept which you need to understand. Not green means what? Red and white. So red and white total probability is 13 by 17. That has to be the answer for not green. But we are having a formula for not green, that is 1 minus probability of getting green. Okay?
Okay, ma'am.
So we will be using the formula only. Let's move to the next one. So here a piggy bank contain 50 paise coin. Okay, 150 paise coin is there. 100 coins are there. And that is 50 paise. 50 coins are there. And that is 1 rupees coin. And 20 2 rupees coin. And 10 coins are there, that is 5 rupees coin. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin will be 50 paise coin? So you don't have to just see this denomination 50 paise, 1 rupees, 2 rupees, 5 rupees. These are just the categories, just like white ball, red ball, black ball. So we take the numbers over here. Okay, don't get confused and don't end up taking 51 and anything. We are taking the numbers, that is from what is the total number of coin. So total number of coins are 150, 60, 70, 80. Total coin is this one. Which coin we wanna have? We wanna have 50 paise coin. Probability of getting 50 paise coin. So we wanna have probability of getting 50 paise coin. 50 paise coin, how many coins are there? 100. So 100 by 180. Is it clear?
Yes, ma'am.
So this is how we will be writing it. Here, most students do mistake with this, because this is also number, 100 is also number, and 50 paise is also number. 50 coins are also number, and 1 rupees is also number. So number, they just end up getting confused. But you don't have to be confused. It's just like 100, let's say black balls are there, 50 white balls are there, 20 red balls are there. It's just like those type of question where you have to focus on which category you want, but eventually you have to focus on how many coins are there, what is the favorable number of outcome. From 100 is the favorable number of outcome, and what is the total number of outcome, that is the sum of all the coins. Now the next one is asking, will not be 5 rupees. Probability of getting coin which is not rupees 5 coin. not be 5 rupees coin. So we know there is a formula which says 1 minus probability of getting 5 rupees coin. 1 minus 5 rupees coin. How many coins are there which is of 5 rupees? 10 coins are there out of 180. Now we just have to simplify it. Is it clear?
Yes, ma'am.
Let's move to the next one. Gopi buy a fish from a shop for his aquarium. The shopkeeper take out one fish at random from the tank containing, there is a tank containing 5 male fish, 8 female fish. What is the probability that the fish taken out is male fish? Very simple. 5 is the favorable number of outcome and total outcome is 8 plus 5, 13. This is the probability of getting male fish. That's it. Now the next one, a game of chance consists of spinning an arrow which comes to rest pointing at one of the number 1, 2, 3, 4, 5, 6, 7, 8 as shown in the figure, and these are equally likely outcome. What is the probability that it will point at 8? So game of chance is there, and this is how a circle is there which is spinning. Here we are having like this, like this, like this, like this. 1, 2, 3, 4, 5, 6, 7, and 8. Now, probability that it will point at 8. So what is the probability that it will point at 8? This question is just like throwing a die question. Okay, 1, 2, 3, 4, 5, 6, 7, 5, 6. These are the outcome. How many total outcome are there? 6. Here, how many total outcome can be there? 1, 2, 3, 4, 5, 6, 7, 8. 8 outcome is the total number of outcome. What is the favorable outcome? We want 8. How many 8 are there? 1 8 is there only. So can you see probability of getting 8
Yes, ma'am.
is 1 by 8? Please don't get confused because the formula itself says that number of outcome, how many number of favorable outcome is there, how many number of total outcome is there. So how many favorable outcome, that is 8 is there, 1 8 is there only. If 2 8 will be there, I'll be writing 2 over 8. Okay. Now the next one is asking probability of getting an odd number. Odd number. Now I will be checking how many odd numbers we are having over here. Okay. So odd number is 1, 3, 5, 7. I can see 1, 2, 3, 4. 4 odd numbers are here. 4 favorable cases are here. Yes or no? So 4 divided by total number of outcome, that is 8. That is the probability of getting an odd number. Now another one is saying probability of getting greater than 2. A number greater than 2. So greater than 2 are 3, 3, 4, 5, 6, 7, and 8. These are the numbers which are greater than 2. Okay, how many favorable outcomes are there? 1, 2, 3, 4, 5, 6. Okay, so 6 numbers are there which are greater than 2 out of 8. Is it clear? Yes, Jasleen and Madiha, is it getting clear to you?
Yes, ma'am.
Similarly, a number less than 9, you will be able to do it. Let's move to the next one. A die is thrown once. What is the probability of getting a prime number lying between 2 and 6, odd number? These are very simple. Prime number, a number which is divisible by 1 and itself. So when when a die is thrown, we are having the possible, all the possible outcomes are 1, 2, 3, 4, 5, 6. So as we know, prime numbers getting a probability of getting a prime number. So prime numbers are a number which is divisible by 1 and itself. 2 is a prime number, 3 is a prime number, 4 is not a prime number, 5 is a prime number, 6 is not a prime number because 6 is divisible by 2 also and 3 also. So 6 is not. 1 is neither prime nor composite. We must know that 1 is not a prime number and 1 is not a composite number also. So 1 we cannot take. How many prime numbers we are having? 1, 2, 3. Out of how many total numbers? That is 6. This is the probability of getting a prime number. So here the concept of probability doesn't matter. Here the concept of identifying prime number is important. You must know what is prime number. Now a number lying in between 2 and 6, probability, so that a number lying in between 2 and 6. So 2 in between 2 and 6 is 3, 4, 5. These three numbers are there which is in between 2 and 6. Okay. So three numbers are there out of 6. Is it okay? And an odd number. You will be able to do the third one, probability of getting an odd number. I'm just moving to the next one, which I believe we need to discuss it. 5 cards, the 10, Jack. There are 5 cards. 10 is there. There are 5 cards. 10 is there. And Jack is there. Queen is there. King is there. And Ace is there. Here it says Ace of Diamonds. Are well shuffled with their face downward. One card is then picked at random. What is the probability that the card is Queen? How many cards are there which is Queen? Anyone? Yes. How many cards are there which is Queen? Jesleen and Madiha.
Yes.
How many queens are there? Any idea? How many queens are there?
4.
4?
Yes.
Yes, 4. But here 5 cards are there only. This is one of the card, this is another card, this is another card, this is another card, and this is the last card. Only 5 cards are there here for this question. One is 10, another is Jack, another is Queen, another is King, another is Ace of Diamond. So here how many cards are there? 5 cards. How many queen is there? 1 queen. Can you see? Are you getting, both of you? In the question itself, it's written that 5 cards. 5 cards. This. Okay, so if we are having only 5 cards, then probability of getting queen, probability of getting queen will be 1 queen is there out of 5 card. Can you see it? So we need to read the question carefully. Okay? From a pack of 52 card, 4 queens are there. But here we are not having pack of 52 cards. Here we are having only 5 cards. So in among that 5 cards, one is jack, one is queen, one is king, one is ace of diamond, one is 10. So how many queens are there? Only 1 queen is there, right? Now the next one says, if the queen is drawn and put aside, we have taken out the queen and kept it aside. Okay. What is the probability that the second card picked up is ace? Can you tell me what is the probability of getting an ace if you have taken out queen and kept it aside? Anyone? How many total
By
cards
5.
are there? Yeah,
1/5.
1 by 5. Is it 1 by 5? If you are taking out one card and keeping it aside, now if you have taken one card, that is queen. Queen came out and you have kept it aside. So this gone from the bunch. Now you have to find the probability of getting ace from the card which is available to you. So how many cards are there? 1, 2, 3, 4. 4 cards are there. What you wanna pick? You want to pick ace. So you will be having 1 by 4. Yes or no?
Yes, ma'am.
So this is how carefully we have to read the question. Okay, in all the scenario where we are taking 1 by 2, again 1 by 2, 1 by 3, 1 by 3, that time we are thinking that this is one of the case and then forget about this case. And again we are freshly taking the question from the very beginning. Suppose dice is there, or suppose a bag is there from where we are picking blue ball, red ball. So every time we are taking a fresh case. Okay, probability of getting red is this by this. Probability of getting blue is, when we are finding probability of getting blue, we are just totally forgetting about the red case, and we are thinking that bag is freshly prepared bag is there where all the balls are as it is. So 5 white ball is there, 2 red ball is there, 3 green ball is there. So probability of getting white is 5 by 10. 5 by 10. Now probability of getting green is 3 by 10. Once we are taking this 3 by 10, we have totally forgotten this 5 by 10. We are not even assuming that part. That one ball we have taken out, now that is not there, or what, we are not even considering that part. We are taking the fresh bag again where 5 white ball, 2 red ball, 3 green ball is there. Until or unless it will be mentioned in the question that whatever you are taking out, that gone, it will be written in the question, then only we have to minimize the total, then only we have to check the list carefully again. Okay, are you understanding?
Yes, ma'am.
Now the next one says, if the queen is drawn and put aside, that means queen drawn and put aside, what is the probability that the second pick card is a queen? So is there any queen? No. What will be the probability of getting queen again? Again getting queen? 0. That is impossible event. And this is what we need to understand in this chapter. The first few questions were very easy peasy question, where we were just checking how many total things are there, how many favorable outcome is there. That's it. Those are not the motto. Those questions you will be able to solve, but you need to understand this type of question when we have to read the question carefully, and accordingly we just have to take the case. Okay, so let's do another one. Now, question number 14 I skipped by mistake. Here it says one card is drawn from a well shuffled deck of 52 card. Find the probability of getting king of red color, a face card, a red face card, the jack of heart, a spade. Please memorize the sequence properly. So do you know the sequences? Among 52, how many uh, red cards are there, how many black cards are there, then how many spade is there, how many club is there, how many diamond is there, how many heart is there? Do you know everything? So you need to memorize this one. Okay, I'm not going to draw over here, rather I'll be showing you. Let me show you. Can you see my screen?
Yes, ma'am.
See, spade, club, diamond, heart. Spade, spade, black, club, black, diamond, red, red, heart, red. Okay, if this seems not that convenient to you, then you can pick this picture, or maybe this picture. Just let me see. Yeah. Just a second now. So please check the sequence. You can get it on Google as well. So check the sequence that out of 52 cards, how many red club, because this one, the same concept, exactly the same concept was there in class 9 also. So I'm not drawing the whole sequence. Just a moment. Okay, let's keep it aside for a while. Let's discuss the next question. You just check the sequence and do let me know whether that is clear to you or not. Or do we need to discuss that over here or not? Okay, now if I'll be taking the next question, it will be, can you see the screen? Okay, let me pick the next question. 12 defective pins are accidentally mixed with 132 good ones. It is not possible to just look at the pin and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is good one. So total 132 good pens are there. Okay, among that 12 defective pens are there. Now all mixed together. Now probability of getting a good pen from there. So probability of getting good pen will be favorable outcome by total outcome. Favorable outcome will be good pen, that is 132. Total outcome will be the mixture of good and bad